Welcome to the NetApp and Mesosphere DCOS demo video. During this video, we will experience deploying an application to the Mesos framework using Docker and the NetApp Docker Volume plugin in order to provide application data persistence. We start by exploring Mesosphere DCOS managing our Mesos cluster. We can see that in this cluster there are a total of 4 nodes available for scheduling containers. We also notice that there are 2 frameworks, one Marathon for scheduling containers, the other Chronos for scheduling periodic tasks. SolidFire will be providing the persistent storage behind our application with the volumes managed by the NetApp Docker Volume plugin. As we can see, there are no existing volumes. At this point, we'll explore a Docker host. This host has the NetApp Docker Volume plugin with it configured to talk to the SolidFire array we just saw. We will also notice that there are 3 QoS policies that have been configured, bronze, silver, and gold, to provide different QoS capabilities. Also note that the host is not aware of any existing Docker volumes locally or from the SolidFire storage array. At this point, we will create 2 Docker volumes. The first will hold the application configuration data. It is 1 GB in size and has the bronze QoS policy. The second is the application data volume. It is 100 GB in size with the gold QoS policy. We can see that the NDVP has successfully created the volumes on the SolidFire array and added them to the host inventory list. We can now switch to the SolidFire management console and see that our 2 volumes have been created. As we would expect, the QoS policies have been applied as appropriate and as specified during the volume create command. Now let's deploy our application. To simplify things, we'll use a JSON configuration instead of filling out fields, and now we can see that our values have been populated for us. In this case, we will use the Docker volume name to specify the persistent volume that we want to provide. We will also specify that we want to pass through the var log directory to our container so that Splunk has access to the local host logs as well as to the persistent volumes that we have created for it. At this point, Marathon is leveraging Mesos in order to deploy the application. It is choosing the nodes in which to schedule the container against and will deploy it as such. It does not matter if the Docker volumes have already been connected to those hosts. So long as the NetApp Docker Volume plugin driver is running on that host, it will automatically connect to the LUN or NFS volume that has been specified and bring it to the host that the container is executing on. We can see that our application is now up and running. This is the first time that our Splunk container has been instantiated, so we have the option of changing our password. Now we need to go in and configure our application data sources. The first one that we will add is the local logs for the Splunk container. This is so that we can monitor what's happening with Splunk itself. After adding the Splunk logs, we will add the host logs. Remember that this was passed through to the container at the /host logs location. After configuring the data sources, we can now see Splunk has begun to ingest and index the data. Looking at our application volumes, we want to bring up the real-time performance monitor. We can then switch back over to our application view and begin executing some queries. Note that we can query the data against both the host log as well as the Splunk log. In this instance, the results are coming from the host itself. The indexing process as well as the queries have generated some I/O on the SolidFire storage system. At this point, we want to see which host is actually running our container. In this instance, it is host number 6. We're going to introduce failure by rebooting this node. This will cause the container to go down. You'll note that Mesos has already noticed that the node has gone down. Likewise, Marathon has already seen that the container is no longer running. It will then recreate the container on a different host that is available and reattach the volumes so that the persistent data remains. At this point, we can browse to the new instance of our Splunk application. Notice that we did not have to reconfigure anything because the etc volume has carried forward. Likewise, all of the ingested and indexed data is still available. We can execute the same query and return the same data as before.